All right, last time we went over a simulated health club example, and really there were a couple of new things that we hadn't covered before that were covered in that class. And one of them is the use of include files. And include files are a good way to make your pages uniform, consistent. Because what you can do is you can put a chunk of any kind of code that you want. Typically, it will be HTML or some mix of HTML and PHP in them. But it could be anything. You could put CSS in it. You could put a mix of CSS and PHP if you wanted to. You could put a JavaScript or a mix of JavaScript and PHP. You know, it's a wild card. You can do whatever you want. But the way we did this is we took sections of our site, sections of our pages that we want to be consistent, and we put them in include files. So I'm going to start off. I'm going to move this to the special web server root location. So we can run it. And I'm going to run it by going to localhost. And I hate when it does that. Google's localhost. All right. There is calling the built-in web page. Let me get rid of those. So I'll only be left with what we're doing in this example. All right, there we go. Notice as we go from page to page, big sections of the page are in common. So our header, our navigation, our footer is in common, regardless of what page we go to. And we've done that through include files, and we put into our include file for the header, we put all the stuff that's going to be on the header. So there's our header. That H1 and paragraph tag is there. So if we look at one of our page is going to have a lot of its content come from other files. Of course, we're going to have the CSS in its own file, so it can be shared among pages. And we're going to have these sections of code, the header, the nav, and the footer in their own include file. So if we look, for example, here's the home page. We have our CSS code in its own CSS file. We have the header and nav in their own include files. And then we have the footer in its own include file. So we're not repeating ourselves. We're not having that code 3 different times because we have 3 different pages. We're having that code one time, and each page refers to that. And of course, it has all the advantages like we experienced with CSS. That is, if we change any of those include files, those changes are made across the site. So we went over that last time. And that's a big thing to consider when you're doing upcoming assignments. Where do I have common code? And first place to think of common code, if you're on a multi-page site, is common appearance of the HTML page. So put your common HTML in an include file. There's a second place where we can use include files, and that is in putting in PHP functions or calculations. So we went over one example last time, and we'll just look at that for a second. Then I want to talk a little bit more about the functions, and then we'll look at the second page where this happens. So if I look at this, no, that's not the one I want. Chart page. Has another include file at the very top, which is heart include. And we'll open that up and take a look at it for a second, and then we'll come back and spend more time on it in a minute here, if I can find it. And in that heart include file, we have a bunch of functions that do calculations related to the heart rate. Calculate your maximum heart rate, calculate your minimum exercise heart rate, your maximum exercise heart rate. And then finally, determine if the heart rate is within the proper range. All right. Now, those are included within the chart page. And the chart page is very similar to our square page that we did as our first PHP example. The only difference is instead of just squaring the numbers, we call these functions. So we run our age from 20 to 80, increments of 5. So we'll do 20, 25, all the way up through 80. We display in the first table column the age. We display in the second column the minimum and the maximum exercise heart range. And we take those and concatenate them together into a message saying value 1 dash value 2 BPM. That's the exercise range. I should probably say that up here. And then finally, we call the maximum function to do the maximum age. So we call those functions. Those functions do their thing and return the answer. And those are plopped into this table that we're forming dynamically by looping through and creating a table row each iteration through the loop. So if we look at this, we end up with that. Now, I want to talk about what makes these functions good, because there are these are not merely examples of functions, they're models for good functions. So I want to explain what it is about these functions that are good and why they're worth emulating. So let's open up a Word document here. I can type stuff in. We'll define this as characteristics of good functions. Number one, they do one thing. All right. When I say good function, what do I mean? All right. In a large degree, I mean that it can be reused in other instances. All right. You'll notice the code that I have in this example between the chart and between the calculator. I use the same functions. That's a good thing. Right? That's a good thing. It's good for a number of reasons. First of all, the rule of do not repeat yourself comes in. We only have one set of functions that do a certain calculation, then there's no chance of them producing inconsistent results. All right. By making the functions do only one thing, it makes them more reusable. All right. So that's the first rule. So let's look at our functions here. Calculate maximum rate. That's what it does. Calculates your maximum heart rate based on your age. Calculate minimum exercise rate, calculate maximum exercise rate, and is your heart rate in the legal, not legal, but a desirable range for exercise? It does one thing, all right? So, good for it. If we look, this function especially uses the other functions to calculate the minimum and maximum and determines if it's between, if it's lower than the minimum, higher than the maximum, or in the range. And it returns a -1. If you're below range, a 0. If you're in range, a 1 if you're above the range. So we don't have code to calculate the maximum rate here. We call that function. If this function did a couple of things, we might not be able to call that function here and that function from the chart. Keep that in mind. Because that function only does one thing, we can use that in two different cases here. So that's the first rule of good functions. They do only one thing. Second, anything the function needs to do its job is passed in as an argument. All right, so what do we need to know to calculate the maximum heart rate? We need to know the person's age. It's the only thing we need to know. All right, at least given this model. Now there might be more elaborate models where age and, smoking status or some other factors come into play. But in this particular situation, using the model that we're using for this, all we need to know is the age in order to do the calculation. And that gets passed in as an argument. To calculate the minimum exercise rate, that's all we need. To calculate the minimum exercise rate, that's all we need. All right? To calculate whether the heartbeat is within range, we need to know the age. We need to know the number of beats that the person has for how many seconds. So this function could be used on, if you notice on the calculate page, we say put in the count of beats per 6 seconds. Some people, that's typically what they recommend for that. So you're not sitting around for a minute or so counting your heartbeats. You just take your pulse for 6 seconds. So this page only requires 6 seconds, but there could be other instances where we have a person's heart rate for 60 seconds or for 30 seconds or for 10 seconds. This function is flexible enough to accommodate it. So everything this function needs gets passed into it. All you need to know to determine if the heartbeat is within range is the person's age, how many beats their heart did, and how many seconds. Okay? That's all you need to do. So everything this function needs to know to do its job gets passed in as an argument. The output of the function is only through the return value. Now, what do I mean by that? Well, let's take, for instance, the maximum heart rate. The maximum exercise, but the maximum heart rate. You pass it the age, you do the calculation, and you return the answer. We're not anywhere in this function referencing some other location on the page to put the answer. For example, you might be tempted to call that function and have that function maybe write to this TD or something like that, or create you might have this function, you might be tempted, okay, here's a better example. You might be tempted to have this function output the TD as well. So we return the TD that contains the maximum heart rate. Well, what's wrong with that? Well, that works if we always want to put the maximum heart rate in a table cell. We might not always want to put it in a table cell. We might want to put it in a text box. We might want to put it in a span. We might want to put it in an unordered list. Who knows where we want to put it? All right. The function doesn't presume we want to put that answer anywhere. So there's no references to the rest of the page somewhere in here. Everything the function needs gets passed in as an argument. The result is returned, and it doesn't make any assumptions about how the return value is used. It just returns the answer. So no assumptions how result is used. So we call this function, and this one puts it in a TD. We could use that code elsewhere to do something else with it. So a sign of a good function is it doesn't make any assumptions how the result is used. It only returns the answer. So function's job, take the input, do the process, output the result. This function is very self-contained then. This function is very self-contained. It only communicates to the outside world via two things: the argument that is given, or arguments that's given, and the return value. Any other information necessary to do the calculation is included in the function. Now let's look at calculate in range, function in range. It takes its argument, it does a calculation, it converts the beats per second into the beats per minute, beats per 60 seconds. It uses this other function to calculate the minimum exercise rate and the maximum exercise rate. So we're using these functions two different ways. If calculate max exercise rate returned a value that and returned a TD, we wouldn't be able to do this, right? Because here we're going to be using the result of that maximum function in an if statement, in a calculation. And that wouldn't be possible if it returned a TD, if this function returned a TD. Either of these functions. So instead, the function returns the answer. It's self-contained. Nothing about the page that it's on, or nothing about how the answer is going to be used, is contained within the function. And the fourth thing I would say is the functions are relatively short. A few of the functions are real short, right? This function is short, right? Even by putting spaces in it to add, to make it more clear to read, it's only 7 lines of code. Likewise with this. Notice this function to calculate the minimum exercise rate. It doesn't recalculate the maximum heart rate for that age. It calls the function to do that. And because that function doesn't return HTML code or anything like that, but only returns the answer, we can then use that in this calculation. So these functions are all small. This function is a little longer. Now, how long is too long? A good rule of thumb I've heard used is if the function can fit on one screen, it's a good function. Well, this function is a little longer than one screen, but keep in mind, I have the font bigger so that you can see it in the video. If I just make it a little bit smaller, it fits entirely on one screen. What's the idea of that? The idea of that is if you can see the entire function, the beginning, the arguments, the end, the return value, it's sort of easier to wrap your head around it. You're not scrolling back and forth and maybe forgetting something that was on the previous screen or the latter screen or whatever. Here you can see and focus on everything that function does. And you can trace the code. This function is particularly well documented, except for one thing. It's well documented in that it says that our age is the age of person. Might be obvious, but hey, whenever someone says obvious, the question is always obvious to who, right? How many pulse beats were counted? How many seconds you took the pulse for? So it defines these, and it returns a value. It returns -1 if the heart rate is below the exercise range. It returns a 0 if it's in a range, and it returns a 1 if it's above range. The only thing wrong with this is it would be good to have an explanation of just exactly what this function does, the purpose of this function. So I would add to it something like this function accepts these arguments and calculates if heart rate within desirable exercise heart rate range. An English language explanation. Remember when you put comments in your code shouldn't explain the programming language. Like if you were going to say in here on line 40, if you were going to comment this line, you wouldn't say if BPM is greater than max, this comment is useless. Right? That comment is useless. Why is it useless? Because anyone that understands PHP knows that that's what that statement does. All right. And if you don't understand what that statement does, then your job is to first show up your knowledge of PHP. All right. A better comment would be something like this. If persons heart rate is greater than the maximum of desired exercise heart rate, set the answer to 1, which means above range. So that's a more useful one. It doesn't simply explain what the syntax means. It says what the purpose of the statement within the function is. All right, use this as your guide when you're doing the assignments. All right, the one that's due tomorrow and the one that's due next week. Use these guidelines of what constitutes a good function. Make sure the function does one thing. And you can tell sometimes if a function does one thing if you look at the name of the function. What do I mean by that? If this said calculate maximum heart range and calculate minimum heart range, that should be a warning flag, right? Because the word and is in there. That implies that it does two things, which I'm not even sure how a function like that would be written because a function can only return one thing. But if you see the word and in your function name, probably not a good function because it probably does more than one thing. If you see a vague function name, do stuff, it's probably not a good function because, you know, what is stuff? Stuff is probably a bunch of stuff, right? In which case that's not a good function. This one is, I wouldn't say this one's vague. I would say that it probably could be more explanatory. Determine if heart rate in range would probably be the full use of full thing of the function. And the fact that I have a comment here that explains what it does sort of alleviates the fact that this is rather tersely named. Okay, use these as a guideline. How do I want to say this? If your code works, that doesn't make it good code. Okay? You could write this any number of different ways, but some ways are better than others. And that's not just me saying, well, I like my way better than your way, right? There's reasons why I like this way of doing this answer. And that's because all of the things I said, these functions can be reused, they're self-contained, they do one thing, they're short, they accept everything as input and then return output. That's the criteria I like, all right? I've seen students do this other ways, violate those rules, but even if they get the correct answer, that doesn't mean that they did a good job coding. If they, for example, have duplicate code, then it's not good because there's duplicate code. If code appears in more than one place, there's always a chance that it could be inconsistent. There's always a chance that you could change one and forget to change the other one, or change one and make a mistake when you change the other one. If what would be American Medical Association comes up with a different rule for the maximum heart rate for exercise or the maximum exercise heart rate or minimum, I could go change this function and it will be changed throughout this little mini website. All right, let's look to see how this is used on the calculator. And the calculator, if you remember, accepts person's age and the heart rate for 6 seconds. I could change this page to say, what's their heart rate, and have person key in the number of seconds. I could do that, all right? But I didn't. But our function's ready for it in case I made that change. That's a good function. It's flexible. So I go enter this in. And it returns and it tells me you're in the optimal heart range. What if I enter in some garbage here? All right, this is good. Tells me that it's not a number. Now, if we notice something here, we just watch the URL. As I type in a value, this goes to another page. All right, at 111, you probably shouldn't be doing too much exercising. It goes to a second page that says check range, and it passes the values of the form on the query string. Notice if I put garbage in, well, that's not garbage necessarily. Tells me the age is not a number. Now, it will allow me to enter in some outlandish values that, like, the person is 1,400 years old and their heart rate is 1 beat in 6 seconds. And it tells me you're above that. So that is a weakness of this application, is it handles some bad data, but not other bad data. So that is another criteria of a good function, and that is it's fault tolerant. And generally what I mean there is that there's some kind of validation done. Okay, so let's look at calculator PHP first. This is a PHP page, even though there's no PHP code in it. Why? Number one, I might decide later on to put PHP code in it. Number two, I can still use include files. So this calculator has PHP code. Oh, I'm sorry, it has HTML code, what I meant to say. Some JavaScript. All right, PHP includes, then the form, and then another include file. Now I have JavaScript here to demonstrate how to do validation on the client side. But I didn't do all the validation here. This is sort of to simulate. This is not true in this case, but in some cases you can do some of the validation on the client side and you could do more validation on the server side. Now in this particular case, I could do all the validation on the client side, but I wanted to show you how this works. So I have a function, validate form, which returns a true or false, and I'm only looking to see if the text age is empty. So I'm looking for this situation. And it will tell me that the age is missing. Notice it happened on the client side, happened on the same page instantly. And it looks to see if the age is an empty string. If it is, then be valid is false. I display the error message. Then I return be valid. So be valid is either true or false. If it's true, that means that the data has passed client-side validation and you can send it to the server to be processed. We're looking for some of the errors on the client side. What does that mean? Well, I have an onSubmit method here that says return validate form. If this returns a false, when I call validate form, that false gets returned to the onSubmit event, and that will cancel the submit. So if there's bad data on the client side, it won't submit the form to the server side. All right. This returns a false. This returns a false. That return of false gets sent to the onSubmit event, and that cancels the submission. So that keeps it from going to the other page. If we didn't have that, it would just go to the other page regardless if there was bad data or not. And that's not what we want. Again, to repeat one more time, in this example, we could do all our validation client side, but I wanted to demonstrate how server-side validation works. So I did some of the validation client side and some of the validation server side. All right, so let's say we can submit. What page is going to be called? checkrange.php. What method? Get. Therefore, it's going to send it on the query string. What's it going to send on the query string? It's going to send pairs of data. It's going to send the name equals and the value of this text box. Text beats equals and the value of this text box, and button submit equals and the value of value. So I'll actually see on the query string that the button submit was pressed. That can be useful if you have a situation where you have multiple buttons on a page. You can tell which button gets paged. There's the URL. Because we said get, it's going to be on the query string. Text equals age. Text beats equals 1. Button submit. Calculate. All right, let's look at the server-side code that processes it. Has that heart function and has a check range include. Now this include file, strictly speaking, would not have to be an include file. I could put this code in this page because this include file is only going to be used on this page. So I'm not going to really worry about the rules for good functions here because this include file is tied to this page. All right, I could just as well included this code right in this page because this was not written with the intent of being reusable. This is written with the intent of making this work this way. A nice streamline. Look how clean this code is. So if you view this, you can see it has these include files. By the way, as I mentioned last time, this is an old example. I use the .inc extension for include files. It would be better to use .php extension for include files. Call a validate form function. If the form is valid on the server side, then display the output. All right. Can't see that validate form function anywhere in here. It is in the check range include file. That also includes, no, that's not, I want the include file. I do want that one, but I also want the include file. Validate form. This one is grabbing data from the query string. So this one doesn't follow my strict rule of having everything passed to it as an argument. But again, this is necessarily tied to this page. So therefore, we're relaxing the rules of a good function. So it's grabbing the age and the number of beats. It's making sure there's a value for age, making sure there's a value for beats, making sure the age is numeric, and making sure the beats is numeric. If any of these are not true, it changes be valid to false. We return false, and instead of getting the answer, we get the relevant errors printed. So if the be valid or if valid is false, that's the end of the line. We just print the error messages. If valid is true, we call display output, and display output gets the number of beats. This page by definition is doing 6 beats, the pulse for 6 beats. I call the in range function, and based on the results of that function, it displays that you're below, in the range, or above the range. Now, I feel a little bad after giving a long lecture about making sure your code is reusable and making sure your functions are good, to show you examples of functions that don't fit that category. All I can say about that is that there are functions that are written specific for a page, and there are functions that are more general in purpose. And if this include file could only be used with that check range page. So since it only can be used with that one page, I'm not interested in making that code reusable. So I'm lax on the rules for a good function. Now, notice that this goes to another page when I calculate. So I put in the age. I get my answer. Excuse me. But it goes to another page. I do have an example in Canvas. This is week 10, right? Yeah. This is the example we'll consider next time. That's good. We don't have to consider it this time because we're running out of time. But we will look at it. I do want to save. This performs what's called a post back. And what's a post back? A post back is when a page calls itself back. I'm going to replace everything in my special place, CINet pub www root, web server root folder. I want you to notice something different about the calculator now. There's another option. Okay, I just added this option so that this example would contain both possibilities. There's a calculator and a calculator post back. The calculator post back does the same thing as a calculator, except notice it doesn't go to another page. It calls itself back a second time. Now this is 2 separate requests because again, notice the URL changes. But the URL that this request is sent to is the same page. Postbacks are often used because it just makes the page cleaner rather than just having code on a page that processes the form. And in that way, if there's an error with something, We get the error message right on the same page and we can edit it. Whereas in the other example, if you remember, there's an error on the page. We had to go back to the calculator to recalculate it. So post-back, there's a lot of advantages of doing that. And we'll consider that next time. If you do have time and you want to, look at that second example, including post-back, and check out the post-back. But for your assignments, it's not a requirement that you do it one way or the other. You can do it in the way that makes sense to you. All right, are there any questions? Are there any questions? I lost my video of you guys. Don't know where it went. I'm going to stop sharing. There we go. There you are. Do you have any questions? No? Okay. We will see you either in lab or we will see you next week. It's good to be feeling at least a little bit better today than I did yesterday. All right. Thank you. Take care. See you later.